Good day, guys. I'm Yanga, and I'll be sharing a talk with you on cropping. This is basically a presentation for guys who normally take selfies, normally go to social networks. I'm sure you're going to enjoy this. Cropping is basically to take the most useful part of the image and remove the non-useful part. Now, the thing is, cropping has actually evolved over the years. We basically use cropping these days on a daily basis. We use them on our smartphones. We use them mainly on social networks. Basically, on our devices would actually crop. Our devices would crop basically to basically limit or to make our memory available. But the way I'm approaching cropping is quite different. The way I'm approaching cropping is we are looking at how the human behaves, the human eye behaves. We're looking at the fact that the human eye can walk into the room and they can start immediately to identify stuff. I can look there and I tell you that is a table. And I can tell you that is a person based on the fact that I can perceive depth. So, out of the cropping literature that is available out there, what are the people actually looking at? I found like there are basically 4 areas which people look at. People would actually look at, most researchers, they look at detecting silent points in the image. And then from detecting silent points, they can actually do their cropping. The other guys, they use segmentation and other methods. And there are few literatures which I've found where guys are actually using training methods. Some other guys, what they do, they combine all the features which are in an image, which mainly are those the height, the width, the depth, and the aspect ratio to actually do cropping. But I approach it in a different sense. The way I approach it, I use the vanishing points. What it does, your eye, in fact, your eye, when it perceives depth, it perceives it as vanishing points. And I actually I've adapted the similar method, and I'm applying that to actually do cropping. Now, the thing is, the benefit of using depth perception is that I can actually find useful information on the image based on depth. But the other limitation is that there's also limited literature on using depth perception on images. Now, someone will ask me then, how do I perceive depth on an image? Because an image is something still. So, if you look, sorry, trying to figure out. Okay. If you look at that image, a human eye will basically, when they look in the road, they'll see a road going up to a point where they don't really see it. We call that point the vanishing point because all of a sudden it just vanishes from your eye. And the eye uses the similar method to find stuff which are far away from it, stuff which actually have depth. So a good example is that if there's a corridor. If you are sitting on a corridor, at the end of the corridor, and you're looking down the corridor, and it's a long corridor, you'll find out the corridor actually vanishes. If you imagine a very long corridor, at some point you won't see. That's because of the fact that your eyes use vanishing points. And in an image, you will actually extract that line, extract that line, extract that line, extract that line, and use equations, intersection, to actually find that point as a vanishing point. Now, it's something a human can see, is basically we perceive it, but we don't know that we see it. is a shape. So in a shape, depth perception works in a different way. All the lines that form the building are extracted where they intersect. Those we get our vanishing points. So how do I do this? The way I do it, I take an image and I copy the image twice. The first copy, I keep the first copy. What I do with it, I generate lines which form a grid on it. Why do I do that? I do so that I can know the location of whatever is shown in the image. Those circles which you see there are basically of equal distance, of known distances. That image is basically whatever I do with the image, I can always implement on the original image. That's why I need two copies. So what I do on the first image, on the original image, what I do, I applied an algorithm called edge detection. So edge detection will give me the edges of the image, the edges of the hand. After I've done edge detection, what I'll do, I will apply an algorithm called hue transform, and it will give me all those lines. Once I'm finished the lines, what I'll do, I'll calculate intersection points, and then I'll map it with an image that actually has locations. That will help me to say, okay, from there to there, I know it's so many cycles, and those cycles are of so much radars. Now, the stage I am at now, I'm at a point where I'm able to generate vanishing points. I'm going to a stage where I'm able where I'll be able to locate vanishing points. Once I'm able to locate vanishing points, what I'll do, I'll crop all unnecessary areas. And then that's basically the stage which will be the next stage, and then the final one will be doing the actual cropping. So, I had a video here, but it's fine. I actually placed a video for you of actually how I do this stuff, but it's not there, it's fine. So these are the results I got. So what I did an analysis over the length of the image and the breadth of the length of the image, which would be the width of the image and the height of the image. And what I did, tried to find out from the start of the image, in the width side, how many vanishing points I could find, and I did the same thing for the height. I did this way because it wasn't easy to actually visualize two-dimensional data in 1D. So on my y-axis, I have a width, I have vanishing points, and then on the x, I have a height there, I have a width there. So if you notice, right there, the center, I have my biggest number of vanishing points. And for the height side, I have the biggest number of vanishing points. If we can go back to this image. From there to there, it's my height. From there to there, it's my width. So now, having this information about vanishing points, I can say, no, I want to do cropping. If I decide that we're going to make a threshold of about 25 vanishing points, which will be running roughly there, which means anything below, on the width side, anything below 200 pixels, I remove. And then anything above 600 pixels, I remove, which means I'll be left with a region from 200 to 600 pixels. So visually, what does that mean? I have, that is my width there. I have my width there. Anything from 200 pixels as depicted there, from there to there I remove. And anything from 600 pixels onwards, from there to there I remove. And on the height side, I don't remove anything except anything above, above 280, which is roughly there. So what is left of the image, which means what will be left, would have removed all the other parts, which is that one, and I'll be left with something which is inside the image. The other thing which was interesting, which was going to be shown if the video was there, was the distribution of the vanishing points over the video. I had a video which had 960 frames, and I found that except there, I'll tell you what happened there and there. The vanishing points were sort of evenly distributed. What happened there is I moved the camera. So when I moved the camera, that introduced a glare. And that glare is a result of that spike in vanishing points. And then I did the same thing right at the end. So the next thing, where to apply this? We've successfully applied this algorithm in robotics. In robotics, we use this to actually limit our processing power, because the algorithm we use is lightweight. And in reducing the processing power, we tend to increase our battery life. The cropping algorithm has already been used in smartphones, and hopefully in future I would get this algorithm to be used also. And in social network, automatic cropping has been used extensively. This is some of the work which have been done. I published a paper in Malaysia early this year containing this work, and I've also submitted my dissertation, which is on this work. But most of the work which is here, which is on both this work, has been inspired by this publication. They actually use this stuff to actually navigate a UAV inside a building. Thank you.